Welcome, ladies and gentlemen. Today we're going to do a little skills review from semester 1. All right, we're going to talk about some midpoint formula, distance formula, and slope formula. So make sure you have your notes, a calculator, and a pen or pencil out. All right, let's get started. So first one here is our midpoint formula. If we recall, the midpoint formula is used to find the middle point, xy, between 2 points. This is our formula for the midpoint formula. M equals, notice the point, so it has in parentheses and it has this comma here. So it's x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So we're going to put down an example for this. Make sure you have everything on this page written down, all right, ladies and gentlemen? So for this example, here's my point. So I'm going to call this x1, y1, x2, y2, and all I'm going to do is plug it into my formula I have here. So m equals x1 is 5 plus x2, which is 6, divided by 2, comma, and then my y's are going to be negative 2 plus 2 divided by 2. Simplify this. M equals 11 over 2, comma, and 0 over 2. Now we're going to simplify this again. So m, our midpoint, is going to be, and we can leave it as 11 halves, or if you want to turn it into a decimal, you may do that too. And then 0 divided by 2 is just 0. So there is our first one. This is midpoint. We're going to be working with this, so make sure you have this example down, all right? Next example is distance formula. Make sure you have everything written down on this one too as well, please. We use the distance formula to find the distance, or the length, between 2 points. Here's our distance formula. Distance equals the square root of the quantity x2 minus x1 squared plus y2 minus y1 squared. So if we're going to do this example, so make sure you have this one down as well. When we have this, I'm going to call this x1, y1, x2, y2. And what we're going to do is we're going to plug it into our distance formula. So distance equals the square root of my x2 is negative 5 minus my x1, which is 7, squared, plus y2, which is negative 10, minus my y1, which is a negative 6, squared. Now I'm going to simplify what's in here a little bit. So d equals the square root. I'm going to simplify this. Negative 5 minus 7 is going to give me negative 12 squared. Make sure it's in parentheses, please, okay? Plus, here, this is going to turn into a positive. So I'm going to get a negative 4 squared. Continue solving this. I get d equals. Now, these are negative, but I take a negative 12 times a negative 12 because that's what squaring means. Multiply it by itself. I get a positive 144 plus negative 4 squared. I'm going to get 16. So my distance equals the square root of 160. Now, for this one, you guys, I'm going to break down into square root, and I'm also going to give you the decimal. So if I break this down, I'm going to get d equals the square root of 16 and the square root of 10. So my distance equals 4 square roots of 10, which is approximately, ladies and gentlemen, when you just take the square root of it, 12.65. So I gave you both the radical answer and the decimal answer. All right, moving on to our last one, ladies and gentlemen. So make sure we have this. This is our slope form, how we're going to find slope. Used to find the lines that are slanted. Remember, this is also important because we'll use this a lot, you guys. It's the rise over run. So make sure you have this written down, okay? to determine if they are parallel or perpendicular or neither. So that's what we're going to be doing, determining whether things are parallel, perpendicular, or neither. So we need to know rise or run. We also need the formula. So here's our formula. Slope equals y2 minus y1 all over x2 minus x1. So if we look at this example, we're going to find the slope of both, and then we're going to determine whether it's parallel, which means that our slopes are the same, right? Or perpendicular, which means they're the opposite reciprocal. Okay? So it's very, very important that we know what parallel and perpendicular mean. So here we go. We'll start with line 1. So my slope equals, here, x1, y1, x2, y2. So my y2 is negative 10 minus my y1, which is negative 6, all over my x2, which is negative 5, minus 7. So this is going to equal, remember this turns into a plus, so I have negative 4 all over negative 12. Now it's very important that we simplify this. So first of all, two negatives are going to make it positive, and then 4 over 12 is 1/3. So the slope of line 1 is 1/3. Now we have to find the slope of line 2. So here's x1, y1, x2, y2. Plug this in. y2 is 1 minus 0 all over 4 minus 1. So the slope of line 2 is going to be 1 over 3. These two slopes are the same. So in this example, these two lines are going to be parallel. All right, ladies and gentlemen, that's all I have for you today. I hope you have a wonderful, fabulous day, and I will see you later. Bye.